Alright, so what we're looking at today is what actually makes lines parallel and perpendicular, and what that it has to do with is the slope. So what I want to do real quick is I want us to take these two graphs, or excuse me, these two equations, and we're going to graph them on this line. Hopefully we remember how to graph. Everybody with me today? So, if this is my first equation, when you are graphing you need two things. You need the slope and you need the y-intercept. We start with the y-intercept. So, looking at this equation right here, what's my y-intercept? -2 is -2, meaning we start on the y-axis at -2. You guys need to pick up your pencils and actually do what I'm doing. I'm not just doing this for me, I'm doing this for all of us. So, my y-intercept is -2. That would be my starting place right there. Okay, and then my slope, according to this equation, is what? 1/2. Thank you. Meaning, we need to rise how much? 1 and run 2. So from here, I'm going to rise 1 and run 2. I know what I forgot to tell you guys. You need a ruler. You need a ruler real quick. So everybody go grab a ruler. Okay, so I'm going to go ahead and connect these. We've got our 2 points. Here's what we're going to do. Before we connect these, it would actually benefit you to do this another time. So I rose 1 and I ran 2. I'm going to do it one more time. Rise 1, run 2. The more points you have, the more accurate your line is going to be. So I went up 1 over 2, up 1 over 2. If you have a lot of points, your line's going to look more accurate. Okay, so then draw a line that goes through your 3 points. And voila. Okay, so this line is this equation right here. Okay, now we're going to do it again, but we're going to do it for this equation. Alright, so I need the y-intercept and I need the slope of this second line. What's the y-intercept of this one? 3. I'm going to start at 3, positive 3. And then what's my slope? 1 over 2 again. So just like before, we're going to rise 1 and then run 2. So from here, I'm going to rise 1, run 2. I'm going to do it one more time just to have more points. Rise 1, run 2. The more points you have, the better your line looks. It's possible if you only do 2 points, your line's not going to look quite perfect. Okay, and then draw yourself a line that goes through those 3 points. Boom. There we go. So, I hope we haven't forgot this. When we get done, we got these 2 nice lines. What do you notice about the 2 lines? They are parallel, exactly. The question is, why do you think these lines were parallel? What do you think, what do these lines have in common that you think made them parallel? Any guesses? Did they have anything in common? The 1/2, which was their what? Slope, right? This had a slope of 1/2. This had a slope of 1/2. If you'll remember, slope is how steep something is. So if they have the same slope, then that means they have the same steepness. They're going at the same sort of steepness. So if they have the same steepness, are they ever going to change? Are they ever going to get closer together? No, they're just going at the same steepness the whole way through. Even if we kept going way off the page, those lines would never cross. So what makes lines parallel? They have to have the same slope. Okay, so make this note down here. Parallel lines have the same slope. Same slope. That is the key. That is what we need to know. Well, y'all, that is extremely easy to identify. Extremely easy. If I told you guys this at the beginning of the day, and we all looked at these equations, we should have noticed very quickly that they both had a slope of 1/2. That's very easy to point out without even graphing it. I could have looked and said, okay, this has a slope of 1/2. This has a slope of 1/2. They're parallel. But obviously the graph just shows us. Okay, so parallel lines have the same slope. That's very easy to remember. Okay, let's look at example 2. All right, right off the bat, do these have the same slope? So they're not going to be parallel. okay? But let's graph them. So for my first one, I want the y-intercept and the slope. What's the y-intercept of the first equation? -4. And that means I'm going to start on the y-axis at -4. And then what's my slope of that first equation? 3/5. Meaning I'm going to rise 3 and run 5. 1, 2, 3, 1, 2, 3, 4, 5. I'm not going to have room to do it again. So I'll just go ahead and connect those. The only reason I did 3 up there is because if your points are real close together, it's easy for your line to not look that good. But these are really spaced out, and I didn't have room to do a third one anyways. The third one just makes it look more accurate. Don't got to. All right, let's look at the second graph, or excuse me, the second equation. What's my y-intercept on this one? +1. So I'm going to start right there. This time my slope is what? -5/3. -5, remember, if that negative's out in front, we're going to move it to the top. -5/3 means I need to rise what? Down 5. 1, 2, 3, 4, 5, and then run 3. 1, 2, 3. I don't have room to do it again. I don't think I need to do it again. Last thing I need to do is connect those points. There we have it. We've got our 2 lines. Everybody's look like mine? What do you notice about the 2 lines? They are. Do y'all agree that these lines look perpendicular? If I tilt my head or if I tilt my paper, does this look like a right angle right here? Yeah, it certainly does. That means they're all right angles. So you're exactly right. These are perpendicular. Now this one is a little bit harder to spot. Okay, so I want everyone to notice this. I want everyone to pay close attention. Up here, parallel lines have the same slope. Again, that's so easy to spot. These slopes are not the same. They do have some similarities though, right? Do you see that they're using the same numbers, first of all? 3/5, 5/3. What's the difference between these slopes? Okay, so first of all, one's negative and one's positive. That has to happen. If this one's positive, to be perpendicular, the other one has to be going down, has to be negative. So that's one thing. One's negative, one's positive. What else do you notice? They're flipped, exactly. So those are the 2 keys. Very good. Perpendicular lines. We'll see. How do I want to put this? One positive, one negative. This will always happen. One's going to be positive, one's going to be negative, and they will be flipped. Flipped slopes. There's actually a word for this. Flipped. It's called reciprocal. But who cares about that? Okay, so what you are looking for is you are looking for slopes that have been flipped, and one needs to be positive and one needs to be negative. Okay, cannot forget, there are 2 things here. Both of those things have to happen for them to be perpendicular. If I just have one positive and one negative, they may not be perpendicular. If I just have flipped slopes, but not this, they may not be perpendicular. Both of these have to happen, okay? All right, let's look at the back. Okay, so I got a couple more examples here. I want to see what happens. All right, example 3, we're going to graph both of these lines. I didn't give you a whole lot of room here. What's my y-intercept on the first line? -5. So I'm going to start here at -5. What's my slope on that one? 3, and we need to put it as a fraction, so 3/1. That is a key. We always want our slope to be a fraction. 3/1, meaning we're going to rise 3, 1, 2, 3, run 1. Because those are close together, I'm going to do it one more time. Rise 3, run 1. I could do it again if I wanted to, but
It's just a single number and it has to be over 1. I don't think it's a further 1.
because we don't ever put a 1 on the bottom of numbers. We just never do. Because it's technically just 3. All right, so for my second graph there, I'm going to start, what's my y-intercept on this one? 2. We're going to start here. This time my slope is what? Negative 1 over 3. Meaning we're going to go down 1 over 3. 1, 2, 3. I'm going to do it again. Down 1, 1, 2, 3. That looks good. And there it is. Pretty 2 lines. What do you think? What are they? Are they perpendicular? Does pick any of these angles? I'm going to look at this one. Does this look like a 90-degree L-shaped angle? Yeah, it does. You tilt your paper? Yeah, that does. Now, notice the slopes. Is one positive and one negative? Yeah. Are they flipped versions of each other? 3 over 1, 1 over 3? Yeah. So if this happens, even if your graph doesn't look perfect, if this happens, one's positive, one's negative, and they're flipped, you know for sure that they're supposed to be perpendicular. Even if you didn't graph it quite perfectly, they are perpendicular. Okay, let's do example 4. Right off the bat, what do you notice about the slopes? They're the same. So what do we expect these lines to look like? Yes. But if they both have a slope of negative 2 over 1, then these lines should be what? Parallel. They should be parallel. We're going to make sure of that. All right, what's my y-intercept on the first equation? 1 is where we will start. We have a slope of negative 2 over 1, meaning down 2 over 1. I'm going to do it again. Down 2 over 1. Down 2, run 1. Okay. For my second line, what's my y-intercept? 4. Again, negative 2, run 1. Down 2, run 1. Down 2. Oh, I don't need to go again. Do the lines look parallel? Did we expect them to be parallel? Why did we expect them to be parallel, you guys? Because they have the same slope. Again, that should be very easy to spot. Parallel lines are going to have the same slope. You should be able to just immediately look and see that. All right. So that's just some that you can see with the graph. Technically, we don't even need to graph this stuff to be able to determine if they're parallel or perpendicular. Okay? For example 6 and 7, all I want you to do is to tell me the slope of a line that would be parallel to the given line. So if I'm talking about parallel, we're looking for same slope. So if this is my line, what would be parallel to this one? A slope of what? I know that sounded confusing. Here's what I want you to do. I want you to give me the slope of a line that would be parallel to this one. Parallel means what kind of slopes? No, parallel means they don't touch, and their slopes are what? The same. So all you got to... Talking about parallel here. Okay, the opposite of okay. Parallel lines have what kind of slope? The same slope, thank you. All I need you guys to do is give me the exact same slope as this line right here. What's the slope does this line have? 5 over 4. So a parallel line would have the same slope. That's all I'm looking for, the same slope, 5 over 4. For example 7, this line has a slope of what? Negative 7. So parallel to that would also be negative 7. Boom, that's it. Well, if we're not graphing it, there's no point. Look, guys, all I'm asking for is the slope of these lines. Because if I'm parallel to it, it needs to be the same. These problems right here, there's nothing to it. These down here, where we're looking at perpendicular, you're going to have to think just a little bit more, okay? So if example 6 and 7 were hard to you, strap on your seatbelt, because this is actually going to be a little hard, because we're going to have to do something. Okay. Everybody stick with me. Write the slope of a line that would be perpendicular to the given line. Perpendicular slopes have two things. What are the two things? We just wrote them on the other page. Perpendicular slopes must be one negative and one positive. Okay, so one positive, one negative, and they must be flipped. Okay, so what we're going to do for each one of these examples is we're going to take the slope that they gave us, we're going to change it to whichever one it wasn't, and then we're going to flip it. Okay, so for example 8, what's my slope? 7/4. So I need to, first of all, change it. Is this positive or negative? Positive. So I need to, first of all, make my new one negative, and then I need to flip it. So 7/4 flips to what? 4/7. Negative 4/7. That's all I'm asking you to do. Take the slope, flip it, and change it. That's not hard. Okay? Take example 9. First of all, what's the slope of example 9? 2. And as a fraction, that would be what? 2/1. I'm going to go ahead and put over 1, just so I don't forget that. Now, what I need to do is I need to, first of all, change it. Is this positive or negative? Positive, so I need my new one to be negative. And then I need to flip it. 2/1 flips to what? 1/2. There you go. That's the new slope. All I'm doing is just finding the perpendicular slope. All right, example 10. What's my slope? -1/4. So first of all, I need to change it. This time it's negative. I'm going to change it to positive. And then I'm going to flip it, and it's going to be 4/1. Or just 4. You don't technically need the over 1. Everybody see what we're doing now? All right, example 11. What's my slope of this line? -2/5. So the first thing I need to do is I need to change it to positive, and then I need to flip it. So what's it going to become? Positive 5/2. Boom. All right, y'all do example 12 and 13 real quick. Take the slope, and then give me the perpendicular slope. All right, for example 12, the slope of this line is what? -5, technically over 1, right? So if I'm going to do perpendicular to that, this one's negative, we're going to do positive, and when I flip it, it's going to become what? Is it going to be positive or negative? Positive 1/5. Why is it positive? Because that one was negative. All right, this one, what's my slope? 3/1. So my new slope is going to be flipped, and is it going to be positive or negative? Negative 1/3. Piece of cake, right? You can do this. All right, real quickly, let me show you a little bit on the worksheet that you're fixing to do. All right, so on this worksheet, these first few problems, write the slope of a line that would be parallel to this one. Literally just means give me the same exact slope that these lines have. You don't even have to think. Just write down the same exact slope. The second section is you're going to give me the slope that's perpendicular. That's what we were just doing. Find the slope, and then change it and flip it, right? Change it and flip it. And then for the last few problems, you're going to graph the lines on the graph that I'm giving you, and then you are going to tell me if they're parallel, perpendicular, or some of them might be neither, okay? So pay attention. Not all of them are going to automatically be parallel and perpendicular. There could be a couple in here that are neither. And then there's a couple more on the back. Same things. Graph the lines and then tell me if they're parallel, perpendicular, or neither. All right, let's do this.